This is a quick introduction to Vehicle Sketchpad or VSP. Now, what is VSP? It's a simple tool for conceptual and preliminary design only. It's designed so that you can rapidly look at different vehicle concepts and designs and have the geometries parameterizable, meaning that you can change different variables and it will retain the relationships between predefined variables that are important for aircraft design. Now, it's important to realize that this is not a tool for detailed design, for CAD analysis. You'll always want to be able to go back to something like SolidWorks to do that detailed CAD, detailed finite element analysis, and other components similar to what you're going to get with that detailed package. Now, the good thing is you can take that VSP model, export it as a CAD file, so you can use that as your preliminary CAD step as part of that. And so if you want to do some really quick geometry, like, oh, gee, I need to generate a wing and a fuselage, you can do that in VSP very quickly, then export it to CAD and generate that. Because what a lot of CAD is not good for is generating unique aircraft geometries due to the shapes of the aircraft. So several pros for VSP. One that's been developed over many years by NASA Langley, primarily NASA, the Aircraft Conceptual Design Group at NASA. Up until last year, you had to have an agreement with NASA to be able to get and run VSP and be a U.S. citizen, and now they've been able to get that approved to be open source, which is great. You can download it, it's free and all that, so that's a really important aspect of it. Runs on most platforms, so there are different versions of it you can use in Windows, Mac, and Linux. Uses XML, which means you can change the file, move the files from system to system very easily. Now, it is scriptable, and what that means is you can take output from another program, such as MATLAB, and have that feed into VSP, so you don't have to run the GUI on VSP. You can have the script go into that, generate that output automatically. So if you're doing a lot of optimization, you'll want to generate a lot of different conceptual platforms and designs. You can put that in as a larger program. And again, we won't be doing that for most of what we use VSP for, but it does become very, very powerful. And so it does interface with those existing design tools as a part of that. There is a group that continually updates VSP. Actually, the conference that we're at right now, NASA has put together a workshop, and so we're learning a lot about the most recent updates to VSP. It does generate meshes if we want to do CFD and some structural analysis and stuff like that as well. And of course, I mentioned before, one of the most important aspects, it is free. Now, some of the features. First and foremost, it's a parameterized modeler. And what that means is each component, for example, the wing, is going to be defined by certain parameters that are linked by those parameter definitions. For example, we have the wing area, S, we have the wingspan, B, we have the aspect ratio, which is defined as B squared over S. So if you change aspect ratio, it'll automatically, change S and B for you. Change S, it automatically changes aspect ratio on B. So these things are linked together with one another. And you couldn't do that, for example, in a CAD program without defining what those parameters are already. I mentioned, it doesn't include that GUI, but doesn't necessarily require it. And we'll give an example of that as we go through the demo. And it is scriptable input and output, as I mentioned before as well. One of the things we use occasionally is something called Model Center, which is an optimization program which allows you to run through lots of parameters and say, okay, first, I want to look at a range of spans, for example, and generate models for certain spans and then do the analysis on that. Now, again, it does have a lot of other features. There's some standard defined elements, that comes with VSP, so you can start putting certain things in like engines and propellers, and do that very, very quickly. Like you couldn't do in a CAD program since you'd have to define those from scratch. Airfoil profiles are often pretty difficult to put into CAD programs. Very difficult to draw an airfoil because it's got a unique leading edge, unique trailing edge. those airfoils are already predefined. You can pull those out. It also computes a lot of the common aircraft parameters that we need to use for analysis, such as the entire surface area of the vehicle, which is important to calculate drag, the planform area, which is important to calculate lift. So it allows you to calculate these directly in VSP as part of the definition. It gets us defined how we typically use those in aircraft design. And there are some other things like vortex lattice solvers and other pieces. And it's always the community is always providing continual updates for these pieces, so it's always improving. Now here's a basic interface. We'll come back and look at this in a bit as well to get an idea of how these things actually work. You have your geometry viewer window over here that lets you look at the actual geometry, all the different components. You have your geometry browser, which allows you to select the different components. And then if you select one of those, it essentially lets you edit that geometry. And we'll provide some examples from that. You can see the different windows here. You can execute a lot of these and develop the aircraft built up from these different components. Now you can have different views as well, so you can look at shaded views to examine the layout, and you can also look at wireframe views as well when you're modifying the actual geometry. So I mentioned it does have various components, so it's to do some aerodynamic analysis, to do some meshing for CFD, and structural analysis. So placement of ribs and spars, determining what those loads will be able to capable of. It's a relatively simple analysis. It's not meant to be very detailed, but it does work as a first pass as to what those loads are. So here in the corner, this is an example of that optimization. So you have VSP module here. It's feeding output to several different MATLAB modules. And again, that will be used to determine aerodynamic analysis, and it works very well for optimization. And it's an example from one of the VSP developers at NASA. Okay, you get VSP from the Open VSP website. So in addition to you have to sign in so you can download it. So they do have a hangar that includes lots of additional aircraft that you can come in and investigate and download and use as essentially a starting point to work with. So one of the things we hope to be able to get out of this as you're working through your project is to be able to provide something that contributes to the hangar as well. Now, and of course, going in and pulling up VSP. So here's our VSP geometry. Again, you're going to pull up the geometry browser first. So if for some reason you don't have the geometry browser, you can go to the geometry and pull that up. And again, that's going to be the geometry over here, the primary piece that you will use. Most of these, again, we won't talk about till later in the semester when we use some of the more advanced components of VSP. Now, to add a specific geometry, all you need to do is come in and take a look and say, okay, I'm going to add, for example, a wing, add, and there it is. And there's your default wing section. And notice as soon as you add the wing, you end up with another window over here which provides your multi-section wing geometry. You can come in and edit that. And you'll notice it has various tabs as components of this. General tabs such as, I want to change the color, be able to change various other options here which we'll talk about later, we don't need to worry about yet. Things like location, so that way you can anchor this to a specific point in your geometry, as well as rotation. Symmetry, how the symmetry is actually defined, which is going to be important, for example, when you want to define something such as a tail section. So, I have a vertical stabilizer, so I don't need any symmetry, for example. Okay. I have the plan form, and this is going to be one of the most important pieces here. as well as the section properties. Now what you'll notice is when we click on this, well, let's look at the plan form first. Plan form controls the general properties of the wing. We have our wing span, okay, have the